Okay, hello everyone. So in this video, we're asked to determine whether the language L, where L in this case is the union of L1 and L2, where L1 is A2n, so in other words, it's an even number of A's, union L2, which is A2 to the n, right? So this is a power of two number of A's. So if taking the union of these two languages is regular or not. So when you're trying to determine whether this is regular or not, you might be very tempted immediately because you see that you have an A2 to the n, and you probably have seen that A2 to the n is one of the classic singleton non-regular languages. Because you see that, you might be tempted to immediately claim that this is non-regular. But you have to beware in this case, right? Because now you have L2 union some other language, right? And so if you have a non-regular language union something else, the result of the union may or may not be regular, right? So you may get something that's still not regular, or you may get something that is regular, okay? So what we need to do is we actually need to carefully think about what the union actually does. So in this case, the union takes all of the strings over A's that are of even length. So the empty string, AA, A4, A6, so on. And it combines them with sequences of A's that were powers of 2. So A to the 0 is A1, A to the 1 is A2, A to the 2 is A4, A to the 3 is A8, and so on. And so what you'll actually notice is that except for A1, all of these other strings, right, all of these other strings will have a length A 2 times 2k minus 1, right? So you have 2 times some integer, right? You don't really care what 2 to the k minus 1 is. So you have A times 2 times some integer, let's say, let's not call it k, let's call it L, right? So you have A 2 to 2L, right? Or 2L number of A's, and this will always be even, right? And so except for A1, the number of A's here is always even. And so in other words, L1 union L2 is all of the strings of even length, right, which absorb, in some sense, all of the strings past A1 in L2, union this A1, right? Because A1 is the only string that doesn't have even length. So L1 union L2 will actually give you all strings of even length along with the string A, okay? So what you kind of have to think about here, or really what's going on, because it might seem surprising, right? You have something that's non-regular. How can it be that if I union it, I get something that actually does now seem to become regular? Well, I kind of like this analogy, which is definitely not my analogy. I didn't think of it, but I like to use it to explain things. So imagine to recognize a regular language, you're trying to sift through pieces of dirt, right? So you have pieces of dirt that are much bigger and pieces of dirt that are much smaller. Or let's think of them as rocks. Actually, rocks is better. So you have big rocks, small rocks, and you try to sift through to only get some size of rocks, right? So you can think of the the language that's non-regular, right? The language that's non-regular, it requires sifting through very specific strings, right? So very specific strings with certain characteristics that DFAs can't recognize. And so because it's much more specific, you can think of a mesh that's very fine, right? You have a mesh, you have a very fine mesh to recognize a to n, a2 to the n, right, for n greater or equal to 0, right? They're a very specific set of strings, right? Whereas for the even number of a's, right, it's binary, right? So you only really your sift is very simplistic, right? Maybe it's just covering half of the mesh, so it's letting half of the rocks go through and the other half not, right? So now what you're doing is you're combining these two meshes together, right? And so what you're doing is you're allowing so I shouldn't have put them top and bottom like this. They should have been side by side, because otherwise it gives you the wrong impression. So now what's going on is I'm going through all the rocks that go through this mesh, right? So I'm keeping only the rocks that go through this mesh, but now I'm also adding all the rocks that go through this mesh, okay? But what's going on is all the rocks, or all the strings that go through here, they're also eventually going to go through here, right? And so what this union is doing is it's creating a space that's much coarser, right? It's creating a language that essentially is much more simple to recognize, right? So you can think of the union in this case, right? In this case, the union creates, and this obviously isn't always true. This is just happening for these two cases, and now I'm just using this analogy to try to help you see what's going on. But really, like, this isn't a rule for everything. This is just, I'm trying to explain something, right? And so in this case, the union creates a much, and I'll use heavy quotes for this, a much simpler language to recognize, right? It creates this language. And this language, hopefully you see, is definitely regular, right? So if I call this language, let's say if I call this L3, L3 is certainly regular, because if we consider the regular expression R, which is AA star plus A, right? Well, this part of the regular expression is there to recognize the patterns of even number of A's. And then this additional regular expression is there just to recognize the string A, right? So then clearly the language denoted by the regular expression R is going to be L3, which is going to be L1 union L2, okay? And so that proves that L3 is in fact regular. But what you needed to do beforehand to prove this was that you needed to recognize what the union was doing in this particular case, which was it was creating a much coarser language, right? Okay, good.